Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video I'm going to talk about percent solutions. When you're looking at the concentration of solutions, there's a number of different ways that concentration can be expressed. And one of those ways is with percent. So if you see 5% followed with W per V, the W represents weight. It's actually mass, but W is used. You might see M used. And when you're working with weight or mass, the unit that's always used is grams. The V represents volume, and volume is always measured in milliliters. So if you see 5% weight per volume, what that means is that you will have 5 grams of solute in 100 milliliters of solution. That's the concentration. If you see 5% weight per weight, that means that there are 5 grams of solute in 100 grams of solution. And lastly, if you see 5% volume per volume, that means that there are 5 milliliters, volume is measured in milliliters, of solute in 100 milliliters, it's a volume, of solution. Notice that with all three, it means 5 per 100, and it means solute per solution. What changes is the units depending on whether we're talking about a mass or a weight or a volume. So understand W means mass or weight. You'll always see grams as your unit. Whenever you see a V, the unit always needs to be milliliters. Weight per volume is the most common. It's what you're going to see in medicine and in biology. Weight per weight would be the most accurate. Volume per volume would be the most convenient, but not as accurate as either of these. If you know that you're dealing with the solution and it says a percent and doesn't indicate which of these it is, always assume weight per volume. Let's take a look at some examples. Our first example says, what is the concentration of a solution containing 2 grams of a solute in 50 milliliters of a solution expressed as a percent? So we can say 2 grams per 50 milliliters, but we want to express that concentration as a percent. We can use this formula to do that. When you're dealing with percents, you will always have percent over 100 because percent means per 100. And when you're dealing with solutions, it's going to be the amount of solute over the amount of solution. So in this case, we don't know percent. That's our unknown, that's X over 100 will equal the amount of solute over the amount of solution. The units tell us what type of percent concentration this will be. That's a weight or a mass unit, that's a volume unit. So when we do get percent, it's going to be weight per volume. We can ignore the units to do the calculation. So to solve this, we're going to cross multiply diagonal x times 50, which is 50x, will equal the product of this diagonal. 100 times 2 is 200. To isolate x, we divide both sides by 50. So we'll just get x equals 200 divided by 50 is 4. It's a percent, and we already discussed its weight per volume. There's also a shortcut that you can use to do these calculations. If we were to take this formula and multiply both sides by 100, we would get percent will equal the solute over the solution times 100. So we could have done that, 2 grams in 50 milliliters times 100, and we would get the same answer doing it that way. So if you're doing a lot of questions where you are calculating the percent, you might want to use the shortcut. Let's take a look at some more examples. In our next example, we have a solution that has 500 milligrams of our solute in 200 milliliters of solution. Units are extremely important. We can't work with milligrams when we're expressing our concentration as a percent. What we need to do is change 500 milligrams to grams. And in order to do that, we simply divide by 1,000 because there's 1,000 milligrams in a gram. So this would be equivalent to 0.500 grams. We don't need those zeros. So we're going to use that for our amount of solute, and this is our amount of solution. Now we can find the percent. Plugging into this formula, where percent is the unknown, so that's my x, I'll have x over 100 will equal solute is 0.5 grams in 200 milliliters of solution. Weight per volume, so I need to make sure that my solute is in grams, my solution is in milliliters. Now I can ignore the units. I'm going to erase the units just so that it makes it look easier for you. Whether you keep them there or not, it's going to be up to you. X times 200, when I cross multiply, will equal 100 times 0.5, which is 50. Divide both sides by 200. This divided by 200 will give me 1x. 50 divided by 200 will be 0.25. We know that x represents the percent, so it's percent, and we know that it's weight per volume because we are working with grams of solute in milliliters of solution. In my next example, I'm finding the concentration as a percent, and I have 8 grams of solute, and I have 40 grams of solvent. So I don't have a volume, I have a mass here, and I don't have solution, I have solvent. So we need to find the amount of solution. The amount of solution is equivalent to the amount of solute plus the amount of solvent. So in this case, we have 48 grams of solution. Now, solution is given as a mass or a weight, so this percent is going to be weight per weight. Again, we're going to use this formula. We don't know percent, so that's our x. The amount of solute is 8 grams. The amount of solution is 48 grams. So the units remind you that it's going to be weight per weight, but we can ignore them when we're doing the calculations. Cross multiply, x times 48 is 48x. 100 times 8 is 800. Divide both sides by 48. And we get x equals to 16.7%, and that will be weight per weight, which we need to indicate with this. Let's do an example with volume per volume. So in this example, we have 12 milliliters of solute in 1 liter of solution. So both of them are volume units, and whenever we're working with volume units, our unit has to be milliliters. We have to change 1 liter to milliliters. So 1 liter is equivalent to 1,000 milliliters. Now we can use our proportion. We don't know percent. We're going to find that. That's our x. The amount of solute is 12 milliliters. And the amount of solution is 1,000 milliliters. So that reminds us it's a volume per volume. Ignoring the units, let's solve. 1,000 times x will equal 100 times 12. Divide both sides by 1,000. And it's a percent. And it's volume per volume. So these examples show how you can take the amount of solute and the amount of solution, and then that one example, the amount of solvent, and be able to express the concentration as a percent. What I'd like to do next is do examples where we know the percent and we're either finding the amount of solute or the amount of solution. We're going to use the same formula. This example asks us to find how many grams of glucose are required to prepare 250 milliliters of a 1.5% weight per volume solution. So I'm going to use this formula to find the amount of solute. I know my percent is 1.5. 1.5% weight per volume means I have 1.5 grams of solute in 100 milliliters of solution. So how many grams of solute are needed for 250 milliliters of solution? Again, we can ignore the units, just make sure that both of these are grams and both of these are milliliters. I'm going to write it without units so it looks easier for you to see how I'm solving it. Cross multiply 100 times x will equal this product of this diagonal, 1.5 times 250 is 375. Divide both sides by 100, and x will equal 3.75. X represents the grams of our solute, which is glucose, so we need 3.75 grams of glucose to make 250 milliliters of solution. Let's try one where we're finding the amount of solution that can be made when we know the amount of solute. How much solution can be made from 10 grams of sodium chloride if a 4.5% weight per volume solution is needed? Percent, we know 4.5. What that means is that we have 4.5 grams of solute in 100 milliliters of solution. We're working with 10 grams of solute, a little more than double. And what we want to find is how many milliliters of solution can we make. So we know it's going to be a little more than double. In order to solve, we can ignore our units. Cross multiply 4.5 times x will equal 100 times 10, which is 1,000. Divide both sides by 4.5. We get 222.2. And it's a volume, it's the amount of our solution measured in milliliters, so it's that many milliliters of solution. Our last example says a solution of glucose is labeled 250 milligrams per liter. Express this concentration as percent. So we know the amount of solute is 250 milligrams. We need to divide that by 1,000 because we need to express it as grams. So it's 0.250 or 0.25 grams. The amount of solution is per liter, so 1 liter. And we need to change that to milliliters. We do that by multiplying by 1,000. So this is our concentration, 0.25 grams in 1,000 milliliters. We just changed each of those units. I'm trying to find percent. In other words, I want to know how many grams of solute are there going to be in 100 milliliters of solution if there are 0.25 grams of solute in 1,000 milliliters. I like expressing it this way first with the units just to make sure my units are consistent. Then I can ignore the units as I'm doing the calculations. Cross multiply 1,000 times x will equal 100 times 0.25, which is 25. To solve for x, divide both sides by 1,000. 25 divided by 1,000 is 0.025. X represents a percent. And we were working with mass per volume or weight per volume. So we should indicate that. In all of these examples, I used the same equation because it allowed me to find either percent, solute, or solution. So use that, pay attention to your units, and know how to solve by cross-multiplying. There are many different ways to measure concentration of a solution. In my next video, I'm going to talk about molarity. See you then.